Here's that pinout for 100 base T. This is the 100 megabit standard kind of Ethernet. And for those of you, again, keeping score and never need to wire these up, a lot of times you never even need to wire one of these things. You just buy all the cables pre-wired. But they're pretty easy to wire if you do need to with crimping. No more soldering XLR connectors and sniffing all that solder. Although I know some people that like that. Anyway, this is a 8-pin connector that you notice really isn't totally used. There's no connection on the 4 and 5 pin or the 7 and 8 pin. What they were thinking back then was upgradability between the RJ11 and the RJ45. RJ11, the regular phone modular cord, has the voice pairs on 4 and 5, or they're in the middle basically. Line 1 and then line 2 is the next one's out. Well, they figured, okay, so we don't accidentally, you can put an RJ11 into an RJ45 jack. They wanted to make sure that you would never have data on the voice pair, so that's why they left 4 and 5 empty in this standard. And they didn't need all 8. They only really needed 4. So they used the 4. They still wire them up, but you really only have those 4. But it's that odd pins 1, 2, 3, and 6 that get connected. And then if you have a shield, and usually you don't, this is UTP, unshielded twisted pair. You could have a shield if you wanted to, and that just gives you a little more RF proofing sensitivity, which in a broadcast facility sometimes comes in handy if you're co-located with your transmission facilities, let's say, and you have real high power RF in the vicinity. Now, meanwhile, this is the standard for gigabit Ethernet. Now, notice these, we do use all the pairs because they're no longer a single unidirectional 2 pairs. These are actual bidirectional, and that's how they get on so much more capacity, because this is 10x more capacity on the same cable. They get more capacity because they're actually using hybrids like phones, like the phone uses, that has the ability to put bidirectional signals on a single pair of wires. And so they just fill it up, and you use all the pairs, and you hook it up to the hybrids on each end of a gigabit path. Typically, you want to have a slightly higher grade of cable. Again, it's the same cable, same 8 pair, same colors of of copper in there. But you want to use a better quality cable just because you want to get the most path length you possibly can. So that's why you go from Cat 5 to Cat 6 mostly. But that's just a recommendation. Most places that have both, you typically color code the cables. And so you just know the yellow ones are Cat 5, the purple ones are Cat 6, whatever. And they're almost interchangeable, but for long paths, you particularly want to be using the right ones. And certainly when you're putting in not just, jack cables patch cables that you're using, but permanent installations, obviously you want to use the best quality cable for the long runs between rooms, let's say, tie lines back between the edge and the core switches. For those that have to make these things up, there's a whole bunch of stuff in the book about wiring the cable and how you do it right, and the path, the appropriate methods of doing it. And then there's the cheat sheet method for those of us whose eyes just can't see these little wires too well anymore. So there's a couple of easier ways of doing it. But again, no solder. So it's a pretty quick and easy kind of thing to do. But even easier is just buying them pre-wired. And then if you do make up your cable, you still do the old wiggle test to make sure it still works. And there's plenty of these little cheap cable testers as well for the RJ45 if you're not familiar with that. But anybody, nowadays a lot of folks doing audio are also doing computer networking, even though they may be for 2 different purposes. You're putting your audio on it, so it's even more critical. Like you would do with audio, just good engineering, make sure you're using the right cables in the right places. You try to keep the number of connectors to a minimum, particularly if you are using shielded cable, because obviously there's no shield around the connector. Some of the connectors actually can continue the shield through, like some people do with XLRs, where you wire that fourth pin. It's a little tricky, but even if you don't, the shield isn't the big thing. It's that the twisting is what uses the common mode rejection, just like it does in an analog or an AES pair. And so the same thing goes. So that's why you try to keep the pairs twisted as close as you can in the connectors, and try to minimize the connections if you can with one long cable instead of two short ones jacked together. There are bending specs on how tightly you should bend them, and that goes when you're talking about permanent installations. And also, the same goes with how much you stretch them if you're pulling cable through a conduit, that kind of thing. And of course, just like audio, you don't run it past the refrigerator if you can help it, or any other things that have a large amount of radiation, electronic or magnetic radiation. Okay. These are pretty standard. The 50 micron gold contacts are pretty standard. They are totally standard in the jacks. They're things that you may need to specify in the plugs on the cables if you're using patch cords. And of course, for obvious reasons, again, the gold doesn't cost that much more in these cases because they're such small contacts, but because of that, you want to minimize the oxidation, just like you would with anything else, and gold is better about that. So here's the connector. This is the way they say just put a 1/4 inch out there. We say put about 6 inches out there and then trim it, because it's a lot easier than trying to squeeze just that little bit. You know, who cares about wasting a couple of inches of cable if you are going to make it up like that. And then once you get them out there and you put in the stripping, you put this connector in, and then that snaps on the top. And here's one with a shield when it's fully assembled. And you see metal rather than plastic on the outside to continue the shield through the connector even, and you see some of that braiding pulled back. The shielded twisted pair is more expensive cable, so you don't do it unless you need to. And then but if you do it, you maintain it throughout so that you can maintain the maximum capacitive barrier that you can. The inductive barrier is taken care of by the twisted pair of the common mode rejection, which does most of the work. Like I said, it's only in cases of extreme RF that you really need the shield. Now, there's another neat thing that Ethernet has, which is kind of like phantom power. There may be some devices on the network that you want to not have to worry about a wall wart power for, so you can power it through the network. And there's two ways of doing it. One uses the spare pairs for just DC, and that is spare pairs if you're in the 100 megabit domain. But if you're in the gigabit domain, you don't have any spare pairs, as we saw. So there you use very much a phantom powered approach, center tap on a transformer. And you can put that on. They'd specify the pairs that they use for it so that the device knows what to look for. So you have, and again, they use 48 volts, familiar for those of us audio for like phantom powering. And typically you do both. And sometimes you put it at the edge, and the switcher actually, the router rather, actually provides this, at least on certain jacks. Other times you can put it in the middle of a path and just have a device that provides the power. It's kind of like a phantom power supply that you just stick run the route a particular Ethernet cable through, and it adds downstream the power to the device or devices. And the devices that don't need it, just ignore it. Again, like a dynamic mic ignores phantom power. So cool little feature. Again, just, you know, another checkbox kind of feature you could use.